Chapter 3. What is Ethereum? Ethereum is often characterized as the world computer, but what does that mean? Let's start with informatics-focused definition, and then try to decode that with a more realistic review of the capabilities and characteristics of Ethereum, while comparing it to Bitcoin and other decentralized knowledge-sharing platforms, or blockchains for short. From the perspective of computer science, Ethereum is a deterministic, but essentially unbounded state machine, consisting of singleton state that is globally accessible and a virtual machine that makes changes to that state. From a more realistic viewpoint, Ethereum is an open-source computing system that is globally decentralized and implements programs called smart contracts. It uses a blockchain coordinate and store adjustments in the system state together, with a cryptocurrency named meter-to-meter Ether, and limit the cost of executing resource. The Ethereum platform allows developers to create efficient, decentralized applications with economic functions built into them. This also decreases or removes censorship while ensuring high availability, auditability, openness, and neutrality, and decreases certain counterparty risks. Compared to Bitcoin, many people would come to Ethereum with some prior knowledge with cryptocurrencies, Bitcoin in particular. Ethereum shares many similar elements with other open blockchains, a peer-to-peer network linking users. Ethereum shares many similar elements with other open blockchains, a peer-to-peer network linking users. A Byzantine fault-tolerant consensus algorithm for synchronizing state changes, a blockchain proof of work using cryptographic primitives such as digital signatures and digital currency, Ether, and hashes. Yet, in several respects, both Ethereum's intent and design are dramatically different from those of the preceding open blockchains like Bitcoin. Although the digital currency Ether is both central to and required for Ethereum's activity, Ether is intended as a utility currency, payable for the use of the Ethereum network as the world computer. Unlike Bitcoin, which has a very small scripting language, Ethereum is designed to be a programmable, general-purpose blockchain, running a virtual machine capable of executing arbitrary and unbounded complexity code. Where Bitcoin's script language is intentionally restricted to a basic true or false evaluation of expenditure circumstances, the language of Ethereum becomes full, implying that Ethereum will act as a general-purpose machine straightforwardly. Blockchain factors. The factors of an open, public blockchain are usually a peer-to-peer, P2P network that links participants and propagates validated transaction and blocks based on a structured gossip protocol. Components of a blockchain. Messages reflecting state changes in the form of transactions. A group of consensus guidelines governing what constitutes a transaction and what constitutes a legal transfer to a state. State machine, which performs transactions according to the rules of consensus. A chain of cryptographically protected blocks that serves as a record of all the state transactions checked and accepted. A consensus algorithm that decentralizes blockchain power by compelling participants to cooperate in implementing consensus rules. A game theoretically sound incentive scheme, e.g., cost of proof of work plus block rewards, to protect the state machine economically in an open world. One or more open source software implementations, clients, mentioned above. Typically, all or most of all these components are integrated in a single device application. For example, in Bitcoin, the Bitcoin Core open source project creates the reference implementation and implements it as the Bitcoin application. Within Ethereum, there is a reference specification, a mathematical description of the program, in the yellow paper. Rather than a reference implementation, there are a variety of clients designed according to the specification of the guide. We use the word blockchain in the past to represent all of the components just mentioned, as a shorthand position to the arrangement of technologies that encompass all of the defined characteristics. Today, however, there are a huge array of blockchains with different properties. We need criteria to help us understand the characteristics of the blockchain in question, such as free, public, global, decentralized, neutral, and immune to censorship, to define the important emerging features of a blockchain network that these components require. Blockchains are not always made equal. If anyone informs you that anything is a blockchain, you haven't received a reply. Then, you need to start to ask a lot of questions to explain what they mean by using the term blockchain. Begin by asking for a summary of the components in the previous list. Then ask whether this blockchain shows the characteristics of being transparent, public, etc. Ethereum's birth. All great inventions address real issues, and Ethereum is no exception. Ethereum was created at a period when people understood the potential of the Bitcoin platform and attempted to push beyond applications for cryptocurrencies. But developers were faced with a conundrum. Either they had to build on top of Bitcoin or launch a new blockchain. Building on Bitcoin meant working under the network's intentional limitations and trying to find workarounds. The limited collection of transaction types, data types, and data storage sizes tended to restrict the kinds of applications that could run directly on Bitcoin. Everything else required additional off-chain layers, and that instantly negated all of the advantages of using a public blockchain. A new blockchain was the only choice for projects which required more independence and versatility while remaining on-chain. But that means a lot of work. Bootstrapping all the network components, rigorous testing, etc. Toward the finale of 2013, Vitalik Buterin, a young programmer and Bitcoin enthusiast, began to think about extending Bitcoin and Mastercoin's functionality further, an overlay protocol that expanded Bitcoin to give basic smart contracts. Vitalik introduced a more simplified approach to the Mastercoin team in October of that year, one that allows for versatile and scriptable, but not Turing-complete, contracts to replace Mastercoin's technical contract language. Although encouraged by the Mastercoin team, this idea was too drastic of a change to fit into their roadmap for growth. Vitalik started sharing a white paper in December 2013 that presented the concept behind Ethereum, a Turing-complete blockchain for general use. A little dozen individuals saw this early draft and gave input, helping Vitalik to improve it. The authors of this book both obtained and commented on an early draft of the white paper. Intrigued by the idea, Andreas M. Antonopoulos asked Vitalik several questions about using a separate blockchain to implement consensus rules on smart contract execution and the consequences of a Turing-complete language. Andreas continued to track the development of Ethereum with great interest, but was in the early stages of writing his book, Learning Bitcoin, and was not personally interested in Ethereum until much later. However, Dr. Gavin Wood was one of the first people to reach out to Vitalik and offer help with his programming skills on C++. Gavin was made the co-founder, co-designer, and CTO of Ethereum. This was the time when the protocol to Ethereum was entirely my own creation. Nonetheless, new participants began to enter the fold from here on. Gavin Wood was by far the most influential on the protocol side. Gavin can also be mostly recognized for the subtle shift in vision from seeing Ethereum as a platform to create programmable property with blockchain-based contracts that can hold digital assets and move them to a general-purpose computing platform according to preset rules. It started with subtle shifts in focus and terminology, and later its effect became stronger with an increasing focus on the Web3 ensemble, which saw Ethereum as one component of a decentralized technology suite, while the other two were Whisper and Swarm. Starting in December 2013, the concept was developed and built by Vitalik and Gavin, together creating the Ethereum protocol layer. The founders of Ethereum thought of a blockchain without a particular intent, which could be designed to serve a wide range of applications. The idea was that a developer could program their specific application by using a general-purpose blockchain like Ethereum, without having to enforce the underlying structures of peer-to-peer networks, blockchains, consensus algorithms, etc. The Ethereum platform was developed to abstract these specifics and provide a deterministic and stable programming environment for applications with decentralized blockchains. Like Satoshi, Vitalik and Gavin not only developed a new technology, they fused modern innovations in an innovative way without existing technologies and presented the prototype code to prove their ideas to the world. The originators worked for years, constructing and refining the vision. And the first block in the Ethereum was mined on July 30th, 2015. The machine of the future had begun to serve the planet. Ethereum, a general-purpose blockchain. The original blockchain, the blockchain of Bitcoin, records the status of Bitcoin units and their possession. You may think of Bitcoin as a distributed state of consensus system, where transactions trigger a global state change, altering coin ownership. State transactions are restricted by consensus rules, allowing all participants to converge on a specific consensus state of the system after mining several blocks. Ethereum is also a computer of distributed state. But instead of monitoring just the state of currency ownership, Ethereum tracks a general-purpose data store state transitions, i.e., a store that can carry any data expressible as a key-value tuple. A key-value data store contains arbitrary values, each referenced by a certain key. For example, the mastering Ethereum value referenced by the book title key in several cases. This serves the same purpose as the random access memory (RAM) data storage model used by most computers of general use. Ethereum has memory that keeps both code and data, and it uses the blockchain from Ethereum to monitor how the memory changes over time. Like a general-purpose stored program computer, code can be loaded by Ethereum into its state machine and run the code in its blockchain, storing the results state changes. Two of the important distinctions from other general-purpose computers are that changes in the Ethereum state are controlled by consensus laws, and the state is distributed worldwide. Ethereum addresses the question, what if we were able to monitor every arbitrary state and program the state machine to create a consensus-based global computer? Ethereum's factors. In Ethereum, the factors of a blockchain system termed in blockchain components are, more specifically, P2P network. Ethereum operates on the main Ethereum network, which can be accessed on TCP port 30303 and operates a protocol known as SVP2P. Consensus rules. The consensus rules for Ethereum are specified in the reference specification, the yellow paper. Transactions. Ethereum transactions are network messages which include, among other things, a sender, receiver, value, and data payload. State machine. Ethereum state transformations are processed via the Ethereum Virtual Machine, EVM, a virtual stack-based machine that executes bytecode, computer language instructions. EVM applications known as smart contracts are written in high-level languages, e.g. Solidity, and compiled on the EVM as bytecodes for implementation. Data structures. The state of Ethereum is stored locally as a database on each node, usually Google's Level DB, which contains the transactions and device status in a serialized hash data structure called a Merkle-Patricia tree. Consensus algorithm. Ethereum follows the consensus model of Bitcoin, Nakamoto consensus, and follows serial signal signature chains and POW weights in value to decide the longest chain and thus the current state. Within the near future, however, there are proposals to switch to a weighted voting system with POS, codenamed Casper. Economic security. Ethereum actually uses a POW algorithm called Ethash, but at some stage in the future, this will inevitably be dropped with a transition to POS. Clients. Ethereum has many interoperable client software implementations, with Go Ethereum, Geth, and Parity being the most popular of these. Ethereum and Turing completeness. You can inevitably experience the word Turing completeness as soon as you start reading about Ethereum. Ethereum, they say, unlike Bitcoin, is Turing complete. What does that really mean? The word refers to Alan Turing, an English mathematician who is known as the founder of computer science. In 1936, he developed a computer mathematical model consisting of a state machine that manipulates symbols by reading them and writing them on sequential memory, which resembles an infinite-length paper tape. Using this construct, Turing sought to provide a logical basis for addressing, in the negative, questions about universal computability, i.e., whether all problems can be solved. In particular, he proved that the stop problem, if it is possible to decide if the program will ultimately stop running, provided an arbitrary program and its input is not solvable. Alan Turing further described a complete Turing system if any Turing machine can be simulated with it. A machine like that is called a universal Turing machine, UTM. The ability of Ethereum to run a stored program on a state machine called the Ethereum virtual machine while studying and jotting down data to memory makes it a Turing-complete device, and thus a UTM. Ethereum can calculate any algorithm which any Turing machine can compute, despite the limitations of finite memory. The innovative idea of Ethereum is to merge the general-purpose computing design of a stored program machine with a decentralized blockchain, thereby producing a distributed single-state, singleton machine worldwide. Ethereum programs run everywhere, but they create a shared state that is protected by consensus rules. Ethereum's creation culture. So far, we've been thinking about how the aims and technologies of Ethereum are different from those of other blockchains that paved the way, like Bitcoin. Ethereum has a very different history of creation too. Technology in Bitcoin is driven by conservative principles. All modifications are carefully researched to ensure that none of the existing structures are distributed. Changes are introduced often only if they are backward compatible. Established customers opt in, but will continue to operate if they choose not to upgrade. By contrast, in Ethereum, the development culture of the group is based on the future rather than the past. The not necessarily serious motto is moving quickly and breaking stuff. If a change is needed, it will be enforced, even if it means invalidating prior beliefs, breaking compatibility, or requiring clients to upgrade. The development culture of Ethereum is characterized by rapid creativity, rapid evolution, and willingness to introduce forward-looking innovations, even though this is at the cost of some backward compatibility. What this means for you as a developer is that if some of the underlying assumptions shift, you must remain agile and be prepared to reconstruct the infrastructure. One of the major challenges developers face in Ethereum is the inherent inconsistencies between applying code to an immutable network and a still emerging development platform. You really can't upgrade the smart contracts. You need to be prepared to launch new ones, move customers, applications, and funds, and get started again. Unfortunately, this also means that the goal of creating more autonomous systems with less centralized control is still not completely realized. Autonomy and decentralized need a little more network stability than you're likely to get in Ethereum in the coming years. To evolve the network, you need to be able to break and restart your smart contracts, meaning you need to maintain some degree of control over them. But on the positive side, Ethereum is very easy to step forward. There's no room for bike shedding, a term that means holding up construction by fighting over trivial details like how to build a bicycle shed at the back of a nuclear power plant. If you start bike shedding, you could unexpectedly discover that the rest of the development team modified the plan while you were busy and digged bicycles in favor of autonomous hovercrafts. Eventually, the Ethereum platform's growth will slow down and its interfaces will be set. Yet creativity is the guiding force in the meantime. You'd better keep up, because nobody's going to slow you down. Why learn Ethereum? Blockchains have a very steep learning curve, integrating several disciplines into one domain: programming, security of information, cryptography, economics, distributed systems, peer-to-peer networks, etc. Ethereum makes this learning curve much less steep, so you can easily get started. But much more lies just below the surface of a disappointing simple climate. When you know and begin to explore deeper, there is often a new layer of mystery and wonder. Ethereum is a fantastic forum to learn about blockchains, and it is creating a huge developer community, faster than any other blockchain network. Ethereum, more than any other, is a blockchain project designed for developers. A developer familiar with JavaScript applications will drop into Ethereum and quickly start generating work code. It's been popular for the first few years of Ethereum's existence to see t-shirts announcing you can form a token in just 5 lines of code. It is a double-edged knife, of course. Writing code is simple, but writing good and stable code is very hard. What this book will teach you is diving into Ethereum and analyzing each part. Starting with a better simple transaction, you can dissect how it operates, create a simple contract, make it better, and follow its path through the Ethereum network. Not only can you learn how to use Ethereum, how it operates, but also why it is built the way it is. You should be able to understand how each piece works and how and why they fit together.